Welcome to the first session of our new webinar series, Belt Drives and Accessories. We'll kick things off by exploring the fundamentals of belt drives. This series is designed for anyone looking to gain a basic understanding of the topic or refresh their technical knowledge. We're glad you're joining us. In the next few minutes, we'll guide you step by step through the fundamentals of belt drives. We'll start by defining what a belt drive is and how it works. Then we'll take a closer look at the advantages of this drive type. After that, we'll explore the two main groups of belts, V-belts and timing belts, and examine their structure, variations, and typical applications. We'll also look at real-world examples from everyday life and industry, followed by some practical tips on storage and maintenance. Finally, we'll give you a preview of our next session. Belt drives are among the oldest and most versatile methods of transmitting motion in machines. They're used in countless applications, from cars and bicycles to complex industrial machinery. A belt drive consists of two pulleys connected by a flexible belt. One pulley is driven by a motor or power source, while the other drives the machine component. When the drive pulley rotates, the belt transfers the motion to the second pulley. By adjusting the pulley diameters, it's possible to increase or decrease speed and even change the direction of rotation. Belt drives are therefore a simple, flexible, and robust way to transmit power between two shafts. Because of their simple design, cost efficiency, and versatility, belt-driven systems are widely used across industries. They absorb shocks and vibrations, help reduce noise, and protect components from wear and damage. Maintenance is straightforward. In many cases, simply replacing the belt is sufficient. Thanks to the flexibility of belts and pulleys, different speed ratios and directions can be achieved. This combination of efficiency, adaptability, and reliability makes them a proven solution for a wide range of applications. The V-belt is the most common type of power transmission belt. It has a trapezoidal cross-section and transmits power through its slanted side surfaces. This type of power transfer is called frictional engagement. The friction between the belt and pulley ensures movement is transmitted. A V-belt is made of elastic rubber reinforced with textile fibers or steel cords, allowing it to handle high tensile forces while maintaining stability. V-belts are used in cars, agricultural machinery, machine tools, and conveyor systems. They're known for being robust, reliable, and easy to maintain. V-belts are available in several different designs, each suited to specific requirements. Wrapped V-belts are the standard version. They're robust, durable, and cost-effective. Notched V-belts are more flexible, allowing the use of smaller pulleys and higher power transmission. Narrow V-belts are stiffer and designed for applications with high loads. Clutch V-belts, such as those used in lawnmowers, enable smooth engagement. Finally, poly V-belts combine several V-shaped ribs into one belt, creating a compact design that's widely used in modern car engines. Unlike V-belts, timing belts have teeth on the inside that mesh precisely with matching pulleys. This creates a positive, slip-free connection, essential wherever exact synchronization is required, such as in camshaft drives or precision machinery. They ensure accurate motion transfer, but must be carefully aligned and maintained to perform reliably. Their greatest strength is precision, while their main challenge lies in the need for exact installation. Belt drives are all around us. In cars, they drive components like the alternator, water pump, or air conditioning compressor. In bicycles and e-bikes, they're increasingly replacing chains, offering quieter operation, less maintenance, and longer service life. In industrial environments, belt drives are used in conveyor systems, packaging machines, and machine tools. They also play an important role in high-tech applications, for example in robotics, medical equipment, or semiconductor manufacturing, where precise and low-vibration movement is essential. These examples show just how versatile the technology is. Belt drives operate reliably in everything from simple household devices to highly precise production systems. The service life of a belt depends not only on how it's used, but also on how it's stored. Since belts are typically made of rubber and fabric, they're sensitive to environmental factors. They should be stored in a cool, dry, and tension-free environment. Avoid direct sunlight, ozone sources such as certain lamps or motors, and contact with solvents. The ideal storage temperature is between 15 degrees Celsius and 25 degrees Celsius, with a relative humidity below 65%. If belts are stacked, the stack height should not exceed 300 millimeters to prevent deformation. Alternatively, belts can be stored hanging, but only with large enough supports to avoid creases. In the next webinar, we'll take a closer look at V-belts and timing belts in detail. We'll discuss tolerances, standards, and specific belt designs. We look forward to seeing you again. Thank you for your attention.